Today we will find out the secret. The smallest thing currently, as far as we humans can study, that is atoms, elements, and compounds. Atoms are the basic building blocks of matter. Everything in the universe is made up of atoms. From the smallest grain of sand to the largest star. Atoms are so small that they cannot be seen with the naked eye. But it can be studied using a high-performance microscope. An atom has a nucleus, which consists of protons and neutrons, and an electron cloud, which consists of electrons. Protons are positively charged, neutrons are uncharged, and electrons are negatively charged. The number of protons in the nucleus of an atom is called the atomic number. The atomic number determines the elements that the atom is made of. Electrons in an atom's electron cloud are arranged in different energy levels, electrons in the lowest energy level being closest to the nucleus. And the electrons in the highest energy levels are furthest from the nucleus. Electrons in atoms are held in orbit around the nucleus by electromagnetic forces. Atoms can combine with other atoms to form molecules. A molecule is a group of two or more atoms bonded together by chemical bonds. The type of chemical bond that forms between atoms depends on the number of electrons each atom has. An element is a substance that cannot be broken down into other substances by chemical means. An element is made up of atoms. It is the smallest unit that retains all of the chemical properties of that element. The number of protons in an atom's nucleus determines the elements that the atom is made of. This is called the atomic number. For example, all atoms with 6 protons in the nucleus are carbon atoms. The number of neutrons in the nucleus of an atom can vary. Atoms of the same element, but with different numbers of neutrons, are called isotopes. For example, carbon-12 has 6 protons and 6 neutrons, while carbon-13 has 6 protons and 7 neutrons. There are currently 118 elements known to science. These elements are arranged on the periodic table, which is a chart that shows the atomic number, symbol, and atomic mass of the element. Elements are divided into 2 main categories, namely metals and nonmetals. Metals are lustrous elements and are good conductors of heat and electricity. Nonmetals are non-shiny elements and are poor conductors of heat and electricity. There are also some elements that are classified as metalloids, which has properties that are an intermediary between metals and nonmetals. Elements are the building blocks of matter. Everything in the universe is made up of elements. Various elements are therefore important to life. Here are some examples of elements: carbon, iron, silver, gold, uranium. A compound is a substance consisting of 2 or more elements that are chemically bonded together. Elements in a compound are combined in a fixed ratio and cannot be separated from each other by physical means. For example, water is a compound made up of 2 hydrogen atoms and 1 oxygen atom. The hydrogen and oxygen atoms are chemically bonded together and cannot be separated by physical means such as distillation or filtration. Compounds can be classified into different categories based on their properties. Some common types of compounds include ionic compounds. These compounds are formed by the transfer of electrons between atoms. For example, table salt, NaCl, is an ionic compound that is formed by the transfer of 1 electron from a sodium atom to a chlorine atom. Molecular compounds. These compounds are formed by sharing electrons between atoms. For example, water, H2O, is a molecular compound formed by sharing 2 electrons between 2 hydrogen atoms, and 1 electron between each oxygen atom and hydrogen atom. Covalent compounds. These compounds are formed by sharing electrons between atoms. For example, methane, CH4, is a covalent compound that is formed by sharing 4 electrons between 1 carbon atom and 4 hydrogen atoms. Compounds are necessary for life, found in all living things, and is also used in a wide variety of products, from food and medicine to electronics and construction materials. Here are some examples of compounds: water, sugar, carbon dioxide, hydrogen peroxide, sodium hydroxide, or caustic soda. The history of the discovery of the atom is a remarkable journey spanning more than 2 millennia, and involves the participation of many scientists and thinkers. The following is a brief overview of the development of knowledge about atoms. Democritus, about 460 to 370 BC. The ancient Greek philosopher Democritus is often credited with having the earliest ideas about atoms. He proposed that everything is made up of indivisible particles, called atoms, which in Greek means indivisible. He suggested that different materials are made up of atoms of different shapes and sizes. John Dalton, 1766 to 1844. John Dalton, English chemist and physicist, considered the father of modern atomic theory. In the early 19th century, he proposed that the elements contain small particles. Indivisible particles are called atoms, each of which has a specific mass and combines in a fixed ratio to form compounds. His work laid the foundation for modern understanding of the atom. J. Thomson, 1856 to 1940. In the late 19th century, J. Thomson conducted experiments that led to the discovery of the electron. He used a cathode ray tube to show that atoms are made up of negatively charged subatomic particles, which he named the electron. This discovery challenges the idea of atoms being indivisible, and led to the development of the atomic model, plum pudding. Ernest Rutherford, 1871 to 1937. Rutherford's famous gold foil experiment of 1909 provided important evidence that atoms have small, dense nuclei at their centers. This experiment led to the discovery that atoms are mostly empty space and that the nucleus is made up of positively charged protons. Niels Bohr, 1885 to 1962. Danish physicist Niels Bohr developed the Bohr model of the atom in 1913. This model describes electrons orbiting the nucleus in discrete energy levels, describe the emission and absorption of light by atoms, and helps us understand atomic structure. James Chadwick, 1891 to 1974. In 1932, James Chadwick confirmed the existence of neutrons, which are neutral subatomic particles in the atomic nucleus. This discovery completed the picture of the modern atom. It consists of a nucleus containing protons and neutrons surrounded by electrons at different energy levels. Quantum mechanics and modern atoms. The early 20th century, primarily through the work of scientists like Werner Heisenberg, Erwin Schrödinger, and Max Born, revolutionized our understanding of atomic particles and elementary particles. Quantum mechanics is a mathematical framework to describe the behavior of particles at the atomic and subatomic level. Advances in particle physics. In the second half of the 20th century and beyond, particle accelerators and EU space experiments, such as CERN, have helped scientists discover many subatomic particles. This confirms the existence of quarks and other elementary particles. Atoms, elements, and compounds are basic chemistry concepts and plays an important role in our daily life in various ways as follows. Energy production. Fossil fuels such as gasoline and natural gas. It is a compound consisting mainly of carbon and hydrogen. Used as a source of energy for transportation, heating, and electricity production. Food and nutrition. Nutrients that we get from food, for example, consist of elements and compounds that provide energy and support various bodily functions. Material and production. Material science relies on understanding the properties and behavior of elements and compounds to develop new materials for construction, textiles, and more. Technology and electronics. Electronic devices rely on the properties of elements and compounds to function. For example, silicon is an important part of the semiconductors used in electronic devices. In summary, atoms, elements, and compounds are the foundation for understanding our physical world, and is important in our daily life in various aspects, from the food we eat to the products we use and the energy we rely on. These basic concepts are essential to meeting many modern challenges and improving our quality of life. If you are satisfied with this video, please press like, share, and subscribe to our channel. To encourage the team to produce good work to everyone every week, or would like to suggest that we make content that interests you, you can comment below the video as well.